For generations, we've looked at Jupiter and believed we understood it, a gas giant, a swirling mass of storms and hydrogen, a leftover from the dawn of the solar system. But what if that understanding was never the full truth? What if Jupiter is more than just a chaotic sphere of weather systems and volcanic moons? What if it is something far more deliberate, and possibly even aware? After almost 10 years orbiting this planetary giant, NASA's Juno spacecraft is nearing the end of its mission. Yet before it begins its final descent into the raging clouds, it has sent back images and data that no one expected, findings that defy the rules of planetary science. What Juno recorded was not just beauty but behavior. Patterns, pulses, and responses that hint Jupiter might not be what we were told, and perhaps never was just a planet at all. The turning point came during Juno's encounters with Io, Jupiter's most volcanic moon. Between 2023 and 2024, the spacecraft flew as close as 1,500 kilometers above Io's surface, capturing surreal scenes of lava fountains erupting dozens of kilometers into space. But the most unsettling part wasn't the sheer violence, it was the precision. Several eruptions occurred in near-perfect synchronization, as if following a hidden clock. Even more puzzling, Juno detected a magnetic fluctuation the moment it passed over Loki Patera, Io's largest volcanic depression. This was no minor anomaly, it was a deliberate oscillation, as though something beneath the moon's crust was aware of the spacecraft's presence. The data also revealed coordinated volcanic activity across locations separated by hundreds of kilometers, something no current model of tidal heating can explain. It raised a disturbing possibility. Io might be responding to more than just gravitational forces. But Juno's mission was never about Io alone. Its true goal was to peer beneath Jupiter's dense, colorful atmosphere. While diving into the planet's north polar region, Juno's microwave radiometer uncovered a startling contradiction. Visible and infrared images showed a massive, stable cyclone at the pole, yet the microwave data showed nothing at its center. No deep radiation signature. No heat source. It was as if the storm existed only on the surface with nothing beneath it. Other nearby cyclones glowed with intense subsurface energy, but this one was hollow, perfectly circular, and eerily calm. One scientist quietly called it, the mask, a storm that looked natural but might have been shaped for a purpose. The strange anomalies didn't stop there. While passing through Jupiter's intense radiation belts, Juno picked up unexpected thermal signals from Amalia, one of the planet's smallest and most overlooked moons. Barely 84 kilometers wide and irregularly shaped, Amalia wasn't expected to hold any surprises. But during Juno's 59th close approach, the moon appeared to glow in infrared, not constantly, but in a steady, repeating pulse. The signal matched Juno's flyby window and faded once the spacecraft moved out of range. At first, scientists suspected tidal heating or electromagnetic induction from Jupiter's magnetic field. But further analysis revealed the pulses were synchronized with a previously unknown magnetic wave coming from Jupiter's equator. It was as if Amalia had received a signal, and responded. Even Jupiter's faint ring system began behaving strangely. While Saturn's rings are well known and bright, Jupiter's are made of thin dust, barely detectable. Yet Juno's sensors found clusters of particles in the outer rings moving in ways that defied gravity. Instead of flowing smoothly, they would accelerate against their orbital path, shift position, then return to normal, all when Juno crossed through a certain magnetic corridor radiating from Jupiter's atmosphere. No natural explanation has been confirmed. One suggestion was that plasma particles were influencing the dust, but the patterns were too precise. One physicist remarked, "They move like they're being told when to move." If so, the rings may not be random debris at all, but part of a functioning system, perhaps even an instrument. And then there's the Great Red Spot, the most famous storm in the solar system, larger than Earth and swirling for centuries. Juno's high-resolution microwave and infrared scans from its 59th and 62nd passes revealed changes that should be impossible. Deep within, temperature gradients fluctuated unpredictably while the surface winds above remained constant. During one pass, Juno recorded a sudden 20% spike in temperature inside the storm's core in less than a minute. Even more baffling, it detected a stream of hot gas emerging from the red spot and moving eastward, like a tendril, before vanishing into the surrounding clouds. Weather systems don't behave like that. They don't send out streams, unless the storm is more than just weather. Some scientists now suspect it could be tapping into hidden energy deep within Jupiter's interior. Others think it might be acting as a kind of planetary pressure valve. Whatever the truth is, the data makes one thing certain: Jupiter is keeping secrets, and Juno may be the first to glimpse them. This storm isn't dying. It's stabilizing. And it may be part of a system too vast and too ancient for us to comprehend. Jupiter's striped cloud bands are driven by immense jet streams, currents of atmosphere that race around the planet at more than 300 miles per hour. But between Juno's 61st and 66th orbits, those jet streams began to behave strangely. In the folded filamentary region of the northern hemisphere, they broke apart into ever-shifting, chaotic patterns, beautiful to look at, but hiding something deeper. When sequential images were analyzed, the movements revealed repeating geometries: hexagons, spirals, mirrored curves, as if the weather itself was tracing fractals. Motion mapping algorithms uncovered loops in these patterns, some completing exactly every 6.2 hours, the length of Jupiter's rotation. Others completed in half that time, or even in quarter cycles, forming repeating quadrants like the gears of a machine. This wasn't just turbulence. It was rhythm. A planetary heartbeat. Was it natural? Or was it computational? Juno's mission also aimed to probe Jupiter's internal structure, particularly its water content. By using microwave radiometry, the spacecraft mapped hydrogen and oxygen across the upper and middle atmosphere. Expectations were clear: high concentrations of water deep near the core. But instead, Juno found an unexpected dryness. The heavy water-rich elements weren't there in the amounts they should have been. This raised an unsettling question: where was the water going? A data release in 2024 revealed massive thermal signatures deep beneath the equatorial zone, too deep for solar heating, too spread out to be volcanic. The readings resembled warm liquid sealed beneath a dense shell of gas. A hidden ocean inside a gas giant. Such a thing shouldn't exist. And yet there it was. Even more unnerving was the vertical motion inside this layer. Columns of material rising and sinking, like convection, or breathing. Was something alive in Jupiter's depths, feeding from within and exhaling into the storms above? Juno's scheduled end will come in September 2025, when it makes its 77th and final dive into Jupiter's atmosphere. But in recent orbits, something happened that no one expected. On its 69th pass, Juno's communications went dark for exactly 3.141 seconds. No solar interference. No hardware fault. Just a complete halt, then a perfect resumption. Engineers noted the duration, eerily close to the number pi. During those seconds, the probe was passing over a location where magnetic resonance had previously spiked, a convergence zone. Publicly, NASA called it a minor telemetry delay. Privately, a handwritten note in an internal document read, "The planet blinked." From that moment, all future flybys were adjusted to steer farther away from that coordinate. Was Juno being kept safe, or being kept out? The probe was never built for this. It was designed to observe, to measure, to send data, not to uncover mysteries that might rewrite what we think planets are. But Jupiter seems to have other plans. What Juno has found isn't just weather or magnetism or volcanic chaos. It's rhythm. Pattern. Coordination. Whispers of design. Moons pulsing in sync with the planet's heartbeat. Storms that vanish when seen with the wrong eyes. Rings that shift without force. Clouds that dance in deliberate, symmetrical spirals. Jupiter stopped behaving like a planet. It started acting like a system. A system with layers we've only begun to glimpse, and defenses we were never meant to cross. Soon, Juno will burn up in Jupiter's atmosphere. But maybe it won't be ending because it's too old or out of fuel. Maybe it will be ending because it has seen too much. Perhaps we haven't been orbiting a gas giant at all. Perhaps we've been orbiting a gate, a processor, a signal tower, or something older. Something deliberate. If that's true, then Jupiter isn't just the largest planet in our solar system. It's our most carefully hidden secret.